Welcome back to another video. Today we will talk about definition of divisibility in section 2.2. So when we divide an integer by an integer, the remainder can be 0. For example, if you want to divide number 136 by 4, what do we have? We're gonna have 12 minus 1 like this. So we have 3 first, right? Because 3 times 4 is 12. And take number 6 down here. And we know that 4 times 4 is 16. Then you have 16 minus 16, which is 0. So 0 right here is the remainder. So 136, according to the division algorithm, 136 and 4, you're going to have 34 times 4 plus 0. So 34 is Q, 0 is R, and R is the remainder. In this case, R is 0. So if we have something like this from division algorithm, in the case where R is 0, that means that 4 divide 136. Okay, so 4 divides 136 because the remainder is 0. Now take a look at the definition of divisibility. So we let A and B be integers such that A is not 0. And A is called a divisor or factor of B. Okay, two numbers A and B, and A is called a divisor of B if and only if there exists an integer Q such that B equal A Q. Okay, so when A divide B, you have an integer Q such that B equal QA. Then let's talk about these two bullets. So if A is a divisor of B, then you can call A divides B, or B is divisible by A. And the notation is A, this bar, and B. Okay, that's the meaning of A divides B. Okay. Another case is if A is not a divisor of B, then what do we have? We can say that A does not divide B, or B is not divisible by A. Okay, which is denoted by A, this bar, slash B like this. Okay. So now, let's go to this example here. Okay. So we take a look at this example. We have 13 divide 195. Why? Okay, so we have to try to find a number that multiply 3 and it turns out to be 195. So let's take a look. Okay, let's multiply by, okay, it should not be 20. It should be, let's use 15. Okay, let's try 15. So you're gonna have 130 plus 65, which is 195. Okay, we can write 13 divide 195. Why? Because, okay, their axis Q in this case, which is 15, which is an integer, such that 195 equal 13 times 15. Okay, that's what we have, right? Now what about is the second case? B minus 5 divided by 30. What is it? Minus 5 divided by 30. What do we have? Okay, we can have minus 6, right? Why? Because their x's, let's say minus 6, okay, which is an integer such that 30 equal to minus 5 times minus 6. Let me see it. Okay, divisor is in the front of Q, right? Where Q is called the quotient. Okay. Okay, 17 and minus 289. Okay. So why can we write this one? Because 17 times 17, what is this number? Is 170 plus, what's the next one? 70 times this number. So it turns out to be 70 plus 49, right? So it turns out to be 240 plus 49. Okay, it turns out to be 289. Got it? So what do we have right here? We get a half. Okay, so we can write 17 divides minus 289. Why? Because their x's negative number minus 7, which is an integer, such that minus 289 equal 17 times minus 17. Okay, D 135 divides 0. Why? Because the x is 0. Because the x is 0, right? And integer 0 such that, okay, such that 135 equal to what? Equal to, okay, when we divide this number by 135 divide 0, because 0 equal to 135 times 0. Okay, and the last one, 4 does not divide 15. Why? Okay, because there is no integer q such that 15 equal to 4q. Okay, there's no such thing as 15 which is a multiple of 4. Okay, and we know that 4 does not divide 15. Okay, so this is how to use divisibility notation. Let's take a look at another example. So I want to find the divisor of the following integers. Let's start with 100. Okay, so we can write, so for 100 we can write 1 times 100, right? If 1 is the divisor. Is 2 a divisor? Yes, because we can find 50 such that 2 times 50 equal 100. Next one is 4. Is 4 times 25, right? And next we can find, if you divide 100 by 10, you will have 10 multiplying 10, and it turns out to be 100. Next, 20. Okay, when you divide 100 by 20, there exists 5 such that 20 times 5 is 100. Okay, next one, 100 equal, if you divide 100 by 25, you have number 4 such that 25 times 4 turning out to be 100. And next is 50, right? 50 divide 100. Okay, why? Because there exists number 2 such that 2 times 50 equal 100. And if you divide 100 by 100, there will be 1 such that 100 times 1 equal 100. Okay, so these are all divisors. Okay, but these are just positive divisors. We can have negative divisors too. For 100, you have, if you divide 100 by minus 1, there exists minus 100. Okay, if you divide it by minus 2, you have minus 50. If you divide it by minus 4, you will have minus 25. For minus 10, you will have minus 10. If you divide by minus 20, you will have minus 5. Okay, another one. If you divide it by minus 25, you're going to have minus 4. If you divide it by 50, you're going to have minus 2. If you divide it by minus 100, you're going to have minus 1. Okay, so these are all divisors, right? These are all divisors. So you might write 100 equal AQ, okay, where A and Q, okay, can be 1, 100, okay, 2, 50, and the list go on and go on. Okay, the last one is 101, and minus 1, minus 100, minus 2, minus 50, and the list go on to minus 100 and minus 1. So what are the divisors? Okay, the divisors of 100 turns out to be plus minus 1, plus minus 2, plus minus 4, plus minus 10, plus minus 20, plus minus 25, plus minus 50, and plus minus 100. These are all divisors of 100. Now let's find divisors of 225. So 225 turns out to be 1 times 225. Okay. And next one is number 5. It's 5 times what number? 45. Okay. Okay. We might use number 9. So 9 times which number? 9 times 25. Okay. And next one, you may have 25 times 9. Okay. And the last one is, oh, not the last one. Well, let me figure this out. I think the last one is 225 times 1. Okay. And then you may have minus, okay, negative numbers like this. Minus 5, minus 45, minus 9, minus 25, minus 25, minus 9, minus 225, minus 1. Okay, that's what we have. This is how to use divisibility. Okay, so what are the divisors? So divisors of 225 are turns out to be plus minus 1, plus minus 5, plus minus 9, plus minus 25, and plus minus 225. Okay, that's what we have. And this is how to use the definition of divisibility. That's it for today, and see you in the next video.